In a stunning development, NASA's James Webb Space Telescope has made a discovery that's left astronomers worldwide astonished. Just weeks after spotting the earliest known galaxy in the universe, the telescope has now detected something even more extraordinary: a supermassive black hole hurtling away from its home galaxy at an astonishing speed of 4 million miles per hour. This groundbreaking find carries major implications and has sparked intense speculation among scientists and space enthusiasts alike about what it could mean for our understanding of the universe. The James Webb Space Telescope, launched to uncover the secrets of the early cosmos, has already delivered breathtaking images of stellar deaths and ancient galaxies dating back to just a few 100 million years after the Big Bang. And its latest discovery is rewriting what we thought we knew about black holes. Traditionally, black holes are seen as cosmic vacuum cleaners, massive objects that pull in everything around them, even light. But this newly observed black hole appears to be doing the exact opposite. Rather than swallowing matter, it's leaving behind a spectacular trail of newly formed stars that stretches an incredible 200,000 light-years into space. This bizarre behavior has scientists baffled. A team led by Yale astronomy professor Peter B. recently shared their findings in the Astrophysical Journal Letters. Supporting data from NASA's Hubble Space Telescope confirms the black hole's trail and suggests that, as it plows through space, it triggers star formation by interacting with clouds of gas and causing them to cool. We're seeing the wake behind the black hole, researchers explained, a phenomenon never before observed on this scale. But the surprises don't stop there. NASA has also released dazzling images of a dramatic galactic merger known as ARP-220, captured by the James Webb Space Telescope. This radiant cosmic collision, glowing in the night sky, represents the merging of two spiral galaxies and shines brilliantly in the infrared spectrum, making it a perfect target for Webb's sensitive instruments. ARP-220 is classified as an ultraluminous infrared galaxy with a luminosity equivalent to 1 trillion suns. In contrast, our Milky Way emits about 10 billion suns worth of light. Located about 250 million light-years away in the Serpens constellation, ARP-220 is the brightest of the three closest galactic mergers to Earth and is designated as object number 220 in the Atlas of Peculiar Galaxies. Roughly 700 million years ago, two spiral galaxies collided, sparking an intense burst of star formation. This led to the creation of a compact region just 5,000 light-years across, crammed with 200 massive star clusters and containing as much gas as the entire Milky Way. Earlier radio telescope studies identified around 100 supernova remnants packed into an area less than 500 light-years across. Later, Hubble's observations revealed that the parent galaxies still sit about 1,200 light-years apart, with each nucleus encircled by a rotating ring of star formation radiating in brilliant infrared light. The latest images from the James Webb Space Telescope reveal a breathtaking galactic merger between two galaxies. Visible in the image are faint tidal tails stretching from the outer edges of the galaxies, clear evidence of the gravitational forces at play. Streams and filaments in shades of red, cyan, and orange represent scattered organic materials within ARP-220. In another groundbreaking observation, scientists were stunned by the discovery of primordial galaxies located at the very edge of the observable universe. Initially, there was skepticism. Some believed these might be closer galaxies masquerading as ancient ones. To verify the findings, the data was shared globally among researchers. Remarkably, the James Webb Space Telescope confirmed the galaxy's authenticity. Thanks to this cutting-edge technology, astronomers can now observe the oldest galaxies ever detected. It's estimated that the light from these galaxies has traveled over 13.5 billion years to reach us, offering a rare window into the universe's early days and its formation history. Recent observations from the James Webb Space Telescope have shed new light on how quickly the earliest generations of galaxies formed. Spectral data confirms that many of these galaxies exist at the very edge of our observable universe, some even farther than what Hubble could ever detect. This finding is monumental, as it validates one of JWST's core missions, to study the early universe by capturing light that has traveled for more than 13.5 billion years. What truly sets the James Webb Space Telescope apart is its ability to detect extreme redshifts, allowing scientists to see deep into the infrared spectrum and observe the universe's very first galaxies. The excitement among astronomers is palpable. This is a major breakthrough in unraveling the history of cosmic evolution. In fact, NASA's latest data, captured using Webb's near-infrared spectrograph and IRSpec and near-infrared camera and IRCam, revealed that 4 out of 6 newly observed primordial galaxies exhibit extreme redshifts. This means JWST is observing them as they appeared just 300 to 500 million years after the Big Bang, long before elements like carbon existed. Considering the universe is estimated to be 13.8 billion years old, the presence of such large, mature galaxies so early on challenges long-standing theories. This has raised serious questions in the scientific community, particularly regarding the Big Bang and cosmological inflation models. Some aspect of the current models, like their conflict with the laws of thermodynamics or the lack of a clear cause for the Big Bang, are being revisited. Even more surprising, JWST has found galaxies nearly as old as the universe itself, casting doubt on what we thought we knew about the cosmos' origin. Theoretical physicist Michio Kaku commented that these discoveries have fundamentally shaken our understanding of the universe's beginning. Previously, early galaxies were believed to be less developed than our Milky Way, but these new observations reveal massive galaxies, some 10 times larger than the Milky Way, forming less than a billion years after the Big Bang. According to Kaku, creating such enormous structures typically takes billions of years, making their early appearance a true cosmic mystery. These revelations might force us to rewrite our textbooks about the universe's origins. Adding another twist, NASA recently tweeted about a newly discovered galaxy cluster that formed just 650 million years after the Big Bang. This protocluster is expected to grow into something as massive as the Coma cluster, Abel 1656. The region is a hub of accelerated galactic evolution, and for the first time, scientists can now measure the velocities of 7 galaxies in the cluster, confirming they are gravitationally bound. NASA compared them to droplets of water from separate rivers that will eventually merge into a mighty stream. Clearly, our previous assumptions about the Big Bang are being challenged. However, more data from JWST may either solidify or completely reshape our understanding. Perhaps the Big Bang really did occur, but the true cause behind it remains a mystery. Either way, answers may be closer than we think. What are your thoughts on these groundbreaking discoveries? Drop your opinion in the comments. And until next time, thanks for watching